So today we're going to talk about conditional probability. To do that, I first need some data. All right. So now that we have our data, let's talk about what this means. This is what's called a two-way table. So in this scenario, we had 500 high school students who were surveyed, and they were asked to report whether they were male or female, and also whether or not their ears were pierced or not pierced. And so the way that we read this table is that this 36 here represents the males who said that they had pierced ears. So in other words, this would be the event male and pierced. The 288 here would be the event female and pierced. 144 would be the event male and not pierced, and the 32 would be the female and not pierced. And then the final column and the bottom row give us our totals. So if we add 36 and 144, we get 180, and that gives us the total number of people who responded that identified as male. And we have the 288 plus the 32 gives us a total of 320 of respondents who identified as female. And if we add those together, we get our 500. The 324 gives us our total number of respondents who said that they had pierced ears. And the 176 gives us our total number of respondents who said that they did not have pierced ears. So let's abbreviate this a little bit. So we want to let P be the event of having pierced ears. And then we generally denote what is called the complement of an event as everything that's not in that event. So I could define the event not P to be all of the people who did not have pierced ears. And we have the nice little rule that says that the probability of not P is equal to 1 minus the probability of P. And that's true for any event. For any event, we have the complement of the event is just 1 minus the probability of the event. So I can abbreviate pierced as P and not pierced as not P. And then I have male, which let's denote as M, and female, let's denote as F. All right, so let's talk a little bit about how to read this table. So let's talk about asking some basic questions about this data. Like, what's the probability that the person surveyed was male? The probability that someone responded that they were male. Well, to do this, we say, well, how many people said that they were male out of every person that responded? So the total number of people who responded is going to be this bottom value here. So in this case, it's 500. And the total number of people who said that they were male was 180. So that gives us 180 out of 500, or 18 out of 50, or 9 out of 25, which would be 36%. And so we can also ask the question of, what's the probability that someone said that they did not have their ears pierced? So what's the probability of not P? Well, we can answer this two different ways. we could say, well, the total number of people that said that they did not have pierced ears was 176 out of the total 500. Or we could do the value of not p is equal to 1 minus the probability of p, which in this case is 1 minus the number, or the probability of someone responding that they had pierced ears, which in this case is 324 out of the total 500, which also gives us the 176 out of 500. So if we want to ask the probability of a single event, right, we look at how many total people said that. So what is the total out of the appropriate row or column, depending on the event, out of the total number of respondents. But what if we want to ask something a little more complicated? What if we want to ask the question of whether or not the gender that someone responds with influences the likelihood that their ears are pierced? So then asking the question of what's the probability of having pierced ears or not isn't really helpful. We want to break it down in terms of a different event, whether they identified as male or female. And so to do that, we use what is called conditional probability. And we define the event of the probability of B given A, written with a vertical line, as the probability of B occurring given that A occurred. So when we write the probability of B given A, we're asking what's the probability that B is going to happen if we know that A happened. So an example of this would be, what is the probability that someone responds that they have pierced ears given that they've identified as male? And so now we want to think about how we would determine this probability off of this chart. So instead of having our probability out of the entire 500, we already know that the people that we're referring to for this event have already identified as male. And so that doesn't include the entire 500 people. It means that we're restricted to this single row right here. We know that they've identified as male, and so that restricts us to only the people who have identified as male. And that means that instead of out of a total of 500 respondents, we only have a total of 180 response. So whatever our probability is, it's out of 180 respondents because we've already determined that they've identified as male. Now, of the people who identified as male, how many of them said that they had pierced ears? And so we can look at that. And of the male category, so remember we're restricted to just this row, the number of people that said that they had pierced ears was 36. So that means the probability of someone responding that they have pierced ears, given that they're male, is 36 out of 180. We can also ask the question of what is the probability of someone responding that they don't have pierced ears, given that they're female. So here we could say, okay, we know that the person who we're interested in has already identified as female, and so in this case we're restricted to this row. And so instead of the total 500 respondents for this set of data, we're interested in only the 320 who identified as female. And out of those 320, we want to ask how many of them said that they did not have pierced ears. And so of those that said they did not have pierced ears, that was 32. So our probability is 32 out of 320, or 1 in 10. We're not restricted for this order, though. We can also ask, what is the probability that someone is female given that they said that they had pierced ears? So looking at this, we know that whoever we're considering here has already said that they have pierced ears. So instead of restricting ourselves to a row, we now restrict ourselves to a column. So we're considering only the column of people who said that they have pierced ears. And so instead of the total 500 respondents, we're only considering the 324 who said that they have pierced ears. And so answering the question of what's the probability that they're female, we say, well, how many of those people who said that they had pierced ears identified as female? That would be 288. And if you think about how we're doing these things, that the number on the bottom, the number in the denominator, is one of these total numbers, which we said were the probability of these individual events. So if we want to know what's the probability of P, right, then we look at this 324. And we said that these individual values inside there are the numbers of respondents who are in M and P. Then this gives us a calculation formula for conditional probability. And that is that we have the probability of B given A is equal to the probability of A and B divided by the probability of A. And so let's recalculate this probability of female, given that they have pierced ears, using this formula. Another way of calculating this is the probability of female given pierced ears is going to be the probability of female and pierced ears divided by the probability of pierced ears. And so from the table, we get that the probability of having pierced ears, we said previously that that's going to be 324 out of 500. And the probability of being female and having pierced ears is going to be 288 out of 500. And if you do a little bit of algebra, you get that this is equal to 288 over 500 times 500 over 324. Our 500s cancel out, and we're left with 288 over 324, which is exactly what we got before. So this gives us a method of calculating these conditional probabilities, either from a table or if we happen to know these probabilities.